In this concept video, we're going to be discussing tests for symmetry. There's 4 different types of symmetry that we're going to go over. There are more than this, but these are the 4 basic ones. We're going to look at the origin, the y-axis, we'll go to the x-axis, and then the line y is equal to x. When we're testing for symmetry, we always want to reference some point a comma b. So a will be the x and b will be the y. For the origin, this is rotational symmetry, and let me give you a function here. We'll go f of x is equal to x to the 3rd power, or y is equal to x to the 3rd power. This function has symmetry about the origin. Let me graph this for you real quick. And 2 to the 8th would be up there, so this is going to look a little bit like this. And then we're going to come over the top and come down this way. Okay. So the deal is with the origin, symmetry about a point is rotational, and we're imagining that if we took this graph centered at the origin here and rotated it about the origin 180 degrees. So we can say that symmetry around the origin is a rotation of 180 degrees. We're wondering if the points line up on themselves. You can imagine if we took this and just rotated it 180 degrees, all of these points in this shape of the graph would line up on this part, and then also this graph, when it's rotated 180 degrees, or this part of the graph, would line up right back on itself. So this function displays symmetry about the origin. If we're looking at a point, let me select a point here, and we'll go this point right here. It's 1, 1. If this function is symmetric about the origin, then the point negative 1 is also on the graph. So the test point for the origin is going to be negative a comma negative b. Remember, we're always referencing an x and a y. And then if this function displays symmetry about the origin, then also negative a, negative b will be a point on the graph. We want to go with this, these letters here in this algebra, because the point 1, 1 could be the point 1, 1 could also be negative 1, but then the other points on this part of the graph may not line up on the bottom. So we want to be careful. We want to generalize this and say that any point AB, negative a, negative b is going to be on the graph. Let's take a look at the y-axis symmetry. And I'll give you, and this is a line symmetry here, so we're talking about this line right here, the y-axis. And I'll give you the function g of x is equal to x squared. So if we graph this one real quick, we can plot some points. 1, 2, 3, 4. That one's a little too high. So we'll come over here. And this will be the function right here. That's the parent function of the quadratics. Just y is equal to x squared. So this function displays symmetry about the y-axis. If you folded this in half on the y-axis, this part would lie right on top of the other. In other words, they're mirror images of each other. If there was a mirror right here on the y-axis, you looked into it, you'd see the graph here, and this shape would appear exactly on the other side of the y-axis. So let's take a look at a point. Let's take a look at a positive point here. Let's take a look at 2, 4, which is right there. And one thing we can say is that if 2, 4 is a point on the graph, and the graph is symmetric about the y-axis, then negative 2, 4 is also a point on the graph. Compare and contrast that with the rotational symmetry about the origin. Here we went right 1, up 1, and then left 1, down 1. But this time the y value stays the same, it's just the x one that's opposite. That's why you see negative a comma b here. We want to generalize that to state that if any point AB is on the graph, then also the opposite of A, comma b is going to be on the graph, or the opposite of the x value with the same y value. We'll take a look at this same type of thinking here with a couple other graphs. And for the x-axis symmetry, we're wondering, is a function symmetric about, or is a graph, I should say, not a function, symmetric about the x-axis? I'll give you this: x is equal to y squared. If we graph x is equal to y squared, we're going to wind up with a shape that looks just like this. Very similar to the other one we graphed, just on its side. And you might know this graph as also, you could do this as y is equal to plus or minus the square root of x. It's the same one, so either or here. And we can continue this down, and obviously this is a little wobbly, but that would be straight. And you can see that if we took this graph, this top part, and reflected it over the x-axis, all these points, even the other points on the graph, would just lie right on top of each other. So this graph exhibits symmetry about the x-axis. Let's pick a point here. We'll go with 4, 2. And we're wondering, if a graph has symmetry about the x-axis, what's that other point going to look like on this other side? Well, this time the x value is the same, but the distance from, or the y value I should say, is going to be -2. The distance is actually the same, but it's in the opposite direction. Okay? So we've got the x value being the same, and the y value is the one that's different. So A will be the same, but then the opposite of B will be different. And we're going to compare that to a reference equation in the examples after this. The line y is equal to x is an interesting one. Let me graph the line y is equal to x for you on this coordinate plane here. So there it is. And then I'm going to give you this function for us to graph. And I'm just going to do, well, I can do all of it, I suppose, but I'll probably just do the positive and the positive right over here. So this is 1 over x. Y is equal to 1 over x. And we know that 1 over 1 is 1. 1 over 2 is 1/2. 1 over 3 is 1/3, and so on. And if we have 1 over 1/2, that's 2. 1 over 1/3 would be 3. And so this graph is going to look just like this. And there's actually another piece of it, and I really should graph that other piece of it. So let's do that actually right now. The other piece of the graph is the negative side. So we know that the graph is going to look a little bit like this. And you can make a table if you want to verify these results. It's going to look just like that. This is just an example of symmetry about the line y is equal to x. You can see that if we folded this paper right on that line, if we folded it in half over, then this piece would lie right on top of this piece. Also, this piece would lie right on top of the other. So this graph exhibits symmetry about the line y is equal to x. Let's do the same thing before, and let's pick a point. And I think I'm going to pick the point 1/2, 2. So the point 1/2, comma 2 is over here on this side of the line. And we want to know if this thing exhibits symmetry about the line y is equal to x, then this point should be this point over here. That's the corresponding point, I guess you could say. And so the coordinates here for this point are 2, 1/2. So in this case, we don't have any opposites really. But what we do have is we do have the x and the y switching spots. So remember our reference was a comma b, and if the graph is symmetric about the line y is equal to x, then b comma a will also be a point on the graph. That works for all of them, by the way. So 1/3, comma 3, and 3, comma 1/3 are 2 points on the graph. This bottom piece can be confusing because this graph also exhibits symmetry about the origin. If you rotated it 180 degrees, it would be on itself. But we're only focused on this portion right here and understanding across the line y is equal to x.